All right, today we're going to start with the third part of experiments. And if you go to your books, we're on page 252, where it says designing experiments control. Okay, we're talking about control now. Okay, it says although random assignments should create two groups of students that are roughly equivalent to begin with, we still have to ensure that the only consistent difference between the groups in the experiment is the type of treatment that they receive. Okay, so they were talking about the effects of cola, right? Whether it's going to be, caffeinated or decaffeinated, right? Okay. And they were talking about, I think they were measuring their pulse rate after that or whatever. Okay. So the point here is that if you have a situation where the Diet Coke and the regular Coke the caffeine-free Coke and the regular Coke has a difference in not only the caffeine, but also the difference in like sugar, okay, then you're not sure. You can't say that it was because of the caffeine or whether it was because of the sugar, right? So you want to make sure that when you're designing the experiment, that both of them have the same amount of everything else, right? Except for that one treatment that you're going to do. Okay, so you want to make sure everything is the same for all the groups. You have to have control of it, okay? So if it says, look at the definition of control, it says, in an experiment, control means keeping other variables constant for all experimental units, okay? So what happens if we don't? What is the end result? What do we call that? There was a specific word that we used.
Confounding.
Confounding, right? Because if you don't have control, you will have confounding issues and you will have different explanatory variables that could be working against each other and you cannot tell the difference or what is actually changing the response variable, right? Okay, all right, good. Next thing is what we call replication. Okay, replication usually in the normal world means that it's something you should be able to replicate, something you should be able to do over and over again. Okay, in statistics, replication has a totally different meaning. Okay, in statistics, replication means that you have enough people. You are doing the study on enough people, okay? In other words, you can't have 10,000 people and pick out two and do the experiment and make, some sort of decisions based upon the two people, okay? So replication here, if you look at the definition of replication, it says in an experiment, replication means using enough experimental units to distinguish a difference in the effects of the treatments, okay, from chance variation due to the random assignment. So you have to be able to overcome the unlucky draw or that kind of thing. So that's why you want to have enough subjects or enough people or enough treatment that you're doing to wherever it's people or whatever it may be. Okay. Little red bullet there. In statistics, replication means using enough subjects. In other fields, the term replication has a different meaning. Okay, we already talked about that. Okay, so let's put it all together. We put it all together, and there's a green box on the bottom of page 253. There's comparison. There is random assignment, control, and replication. So those are the four things you have to look at to make sure it all gets included there. Okay. Let's go ahead and do the example there where it says the physician's health study. Okay, there's a problem there. Okay, I'm not going to read the whole thing. I'm going to give you guys 2 minutes to read it on your own. So please read that on your own. Okay? So let's go ahead and read the questions associated with this. It says, A, explain how this experiment used comparison, okay? So they are using a design that compares what? The two active treatments to a placebo, right? So the two active treatments were what? The beta-carotene and the aspirin, right? Okay. And in B, explain the purpose of randomly assigning the physicians to the 4 treatments, okay? Random assignment helps ensure that the 4 groups of physicians were roughly equivalent. They're roughly equivalent, right? Okay. C, name 2 variables that were controlled in this experiment and why it was beneficial to control those. Okay, so what were the 2? The experiment used subjects of the same gender and same occupation, okay? Okay, using only male physicians helps to reduce the variability in the response variables, okay? D, explain how this experiment used replication, and that is what? We have 5,000 subjects, so that's quite a few, right? And that's just, we have enough people to begin with, right? Okay, that was what replication was. Okay, so that was how that goes. So let's go ahead and now look at completely randomized designs. Okay, if you look at that, on page 255, there is a flow chart there. Get very familiar with this flow chart. When you, and this happens quite often on the AP test, they will ask you to do a design of an experiment, okay? And when they ask you to do that, that flow chart is what you're going to draw. Okay, you're going to draw that flow chart. Okay, so you have 20 volunteer students, you randomly assign them, and you have group 1 and group 2, they each have 10 students, and then you go treatment 1 is caffeine and treatment 2 is no caffeine, and then you compare changes in the pulse rates. Okay, so everything has a flow chart there, right? Okay. Now, when they're asking you to do the complete randomized design, okay, you also have to explain how you're going to do the random assignment, okay, and what treatment, how you're going to do the treatment 1 and treatment 2. Okay, you just can't go ahead and draw that. You also have to explain in words how you're going to do the random assignment, okay? Green box, in a completely randomized design, the experimental units are assigned to the treatments completely by chance, right? Okay, flip the page, let's go to the example. Chocolate milk and concussions. Concussion-related measures improved in high school football players who drank new chocolate milk, announced a recent headline. In the study, researchers compared a group of concussed football players given a new type of chocolate milk with a group of concussed football players who received no treatment. Okay. A, explain why it isn't reasonable to conclude that the new type of chocolate milk is effective for treating high school football players with concussion based on this study. Well, it is possible that the group who received the type of new chocolate milk because they knew they were being treated and expected to get better. What is this called?
Placebo effect.
It's the placebo effect, right? It's a placebo effect, right? Okay, so basically what are they lacking here? They're lacking the single blinding, right? There's no blinding here, right? B, to tell the effectiveness of the new type of chocolate milk, you recruit 50 high school football players who suffered a concussion in the previous 24 hours to participate in an experiment. Write a few sentences describing a completely randomized design for this experiment. Okay, so the solution says, number the player 1 through 50s, do a random number generated from your calculator and put in 25 different integers from 1 to 25. And so you would randomly assign the players that way. Then you would give the regular chocolate milk to the remaining 25 players and you would compare them, right? Okay, so that's that. So we'll stop right here. Take our breath, take a breath.